It's an honor and it's a real pleasure to be here, and to be here in person. I will argue that gestures can be used to probe knowledge of grammar and address the question, what is lexically encoded in memory and what is discovered on the fly in a productive fashion. Now, when one talks about gestures, one usually thinks of co-speech gestures. So things, my enemy, I will punish, where the violent gesture, for which I apologize, tells you that the punishment will be physical in nature. Co-speech gestures are super interesting, but in a way they're too common for my purposes. I want to focus instead of less common gestures, which fully replace some words and are called for this reason pro-speech gestures. So an example, still with apologies, would be, my enemy, I will. Okay, and now the gesture has replaced the verb. Now, I will argue that we can use these uncommon pro-speech gestures to probe the productivity of inferential types in language, things like assertion, presupposition, implicatures, etc. And they can also be used to probe the productivity of syntactic rules, especially syntactic rules that exist in sign language and can sometimes be imported into gestures. And the take-home message will be that there is far more productivity than one might have thought, and certainly that, than I used to think. So let me turn to the first question. Productivity of inferential types. This is based on the observation that meaning in language is divided into a number of types. So in logic, you convey information by way of entailments. In language, you convey information by way of entailments, but also presuppositions, implicatures, and a whole range of complicated inferential types. So to show you a difference between entailments and presuppositions, so entailments are produced by assertions, and here is a very simple property. If I tell you Anne has a dog, you get an entailment that, and an inference that Anne owns a dog. And of course, if you say Anne doesn't have a dog, you lose the inference. That's exactly what you expect on the basis of logic. But presuppositions are different. If you say that Anne spoils her dog, you still have an inference that Anne owns a dog. But now add a negation to this. Anne doesn't spoil her dog. You preserve the inference that Anne has a dog. Now, a standard claim is that a large part of this typology, which I have illustrated on the example of assertion versus presuppositions, is much broader. A large part of this typology is encoded in the lexicon, in things that we memorize about words. Here about the word her, for instance, or the definite article the. But now the new claim will be that close to none of the typology is lexical. And to give you an idea of the argument, I want to start informally with a really weird gestural example. So I talk about another room, and I tell you, the light bulb in that room, I will. Okay, and what you understand, probably, I don't know whether people could see this online, is I will unscrew the light bulb in that room. But you also get another inference. You get an inference that the light bulb is positioned high. And if, in fact, I could modulate my gesture to convey extremely fine-grained information. For instance, I could tell you the light bulb in that room, I will, and that means it's positioned to the right. Or even I could say the light bulb in that room, I will, and now I convey the fact that it's too high for me because I am not tall enough to reach the light bulb in that room. So this is also information conveyed by the gesture. But now if you add a negation to this, if you say the light bulb in that room, I won't, what you're denying, what I'm denying is that I will unscrew the light bulb. But the information which is preserved is that the light bulb is positioned high, and this is a presupposition. And this is a pretty uncommon gesture, and you can get them to be much more uncommon than this. So I will give you a brief idea of a study that pertains to 7 inferential types. We'll discuss the ones in green. I've just given you an idea of the case of presuppositions. The ones in yellow have been investigated with Thiel and Chamla in an experimental fashion, and the others have been investigated in a non-experimental fashion in an earlier paper. So the logic will be the following. The informational content of new iconic gestures, like the light bulb example, and even visual animations can be understood without prior exposure. Why? Because of their iconicity. This makes it possible to see how their new informational content is divided among the inferential typology. And the result will be that most or all of the inferential typology can be replicated with iconic gestures, and even if you want to ensure that there are things that people have really never seen before, with visual animations. And so that will establish the need for general, possibly even non-linguistic algorithms. An additional part of the argument, just like on the case of the light bulb example, which could be modulated so as to give you very, very fine-grained iconic information, is that this fine-grained iconic information shows that the way people understand these gestures is not purely by translation in words. Because if you try to convey the differences among the various light bulb examples in words, that's going to be super complicated. And the last point will be that absence of prior exposure to these examples can be ascertained by replacing gestures with visual animations. So I'll illustrate this on just a couple of cases. So the first case is the case of scalar implicatures. That's, in a way, a dry run or sanity check, because basically all linguists more or less agree on how basic scalar implicatures are produced. They know it's a productive mechanism. They expect that this is going to be productive in all sorts of new stimuli. So an example of a direct implicature is Bill has a dog. You get the inference that Bill has exactly one dog. Linguists posit that the reason for this is that Bill has a dog means Bill has at least one dog, but then there's a competition between a dog and 2 dogs. And by negating Bill has 2 dogs, meaning, you know, Bill has at least 2 dogs, you get that Bill has at least 1 dog, but not at least 2 dogs, and therefore he has exactly 1 dog. Now, you might wonder, why do people need to say such a thing? Why do you not say that lexically a dog means exactly 1 dog? You need to say this because under negation, a dog does not mean exactly 1 dog. It means at least 1 dog. So if you say Bill doesn't have a dog, it means it has none. Okay, and so that's basically the heart of this argument for implicatures. And there is a similar argument for new implicatures that arise under negation. If you say Bill doesn't have many dogs, you get an inference that he still has some dogs. Okay, and it's in fact exactly the same reasoning. You say he doesn't have many dogs. You could have said Bill doesn't have a dog or Bill doesn't have any dog. This would have been more informative. And then people argue that speakers try to be as informative as possible. If they avoided the more informative claim, it's that it was probably false. It's exactly the same logic. And basically what we did was we replicated this logic with iconic gestures. Okay, so I'll give you an idea of how this works. So John is training to be a stunt driver. Yesterday at the first mile marker, he was taught to, and now you have a large wheel turning. I'll paraphrase them because I don't know what people can see online. Today at the next mile marker, he will, okay, and so now I have a small wheel turning, which is contrasted with the large wheel turning that you had before. And what subjects get in this example is today at the next mile marker, he will turn the wheel but not completely. Okay, why? Because this gesture, the small wheel gesture, competes with the large wheel gestures. And so you get an implicature that you could utter the small wheel gesture, you could not utter the large wheel gesture. Now, of course, you might wonder whether it doesn't just show that John will With a small wheel gesture, maybe this just means he will turn the wheel exactly like this. But again, when you add a negation, you see that this is not what's going on. If you say John will not, you get the meaning that he will not turn the wheel at all, as opposed to he will not turn the wheel exactly like this. Or at least that's the dominant reading. I'm kind of simplifying a little bit the experimental data for the sake of simplicity. Now, you can get indirect scalar implicatures as well. So the new implicatures that arise under negation, here is an example. Bill is training to be a stunt boat driver out by the first buoy. He decided to, so complete wheel turning, for those who didn't see it. But the second one, he did not, so now small wheel turning. And the target sentence is, at the next buoy, he will not, and now you get the large wheel turning. And of course, what you negate is that he will turn the wheel completely. So it's not the case that he will turn the wheel completely, but you also get a positive inference. Then he will turn the wheel, just not completely. So in other words, now we have replicated the example that we had a couple of slides back, with Bill doesn't have many dogs, which gave rise to the positive implicature that he has some dogs. And here we've done the same thing with turn the wheel completely, giving rise to the positive inference that he will turn the wheel somewhat. Okay, so in this experiment, there was an additional condition, which was to actually assess that the kinds of iconic modulations that I discussed with the light bulb example exist in our data as well. So for instance, we modified the size of the wheel. It could be a small wheel, it could be a large wheel. And of course, we checked that subjects got different inferences from the small wheel and from the large wheel, but that's kind of trivial if you've seen the light bulb example. And then the last step was you could say, well, you know, what's the big deal about these things? You say these are rare gestures. How do you know they're rare gestures? Right? And so the point was, let's really create something that subjects have never seen before. Let's replace gestures with visual animations. Okay? And so particularly Lin Qiao and Emmanuel Chamla came up with these very, very, very clever animations. And it was the same logic, except that we replaced the gestures with little drawings or very, very simple animations. So it was John, the alien, has been training on the punching bag at the gym. At last week's workout, John had a lot of energy. He was able to, and then you saw this picture with a lot of stars. And then you say, this week, John will, and you just see a single star. And lo and behold, what you got is that the second one was taken to mean John will punch, but not a lot. And same thing, if you put this on the negation, this week John will not, and then a single star, you don't get the meaning he will not punch once. You get the meaning he will not punch at all. So that's basically exactly the same logic as before, just making sure that people have never seen the stimuli before. So this is, you know, what people sometimes call zero-shot learning. They haven't seen the stimuli, and they learn without prior exposure. Okay, so now I want to get back to the hard case, because implicatures, in a way, anyone would have told you this is productive. But how about presuppositions? Okay, presuppositions, that's much harder. So the standard line is that whether a word triggers a presupposition is a lexical requirement. This is something that you encode once and for all in your memory. There's presuppositions all over the place. I give you the example of her dog. But you know, presuppositions come in many varieties. You can say, Mary stopped smoking. Mary continued to smoke. Mary regretted smoking. They all trigger the presupposition that Mary smoked before. How do we know that it's a presupposition? We know it's a presupposition by applying a variety of tests. So for instance, the inference is preserved under negation. If you say Mary didn't stop smoking, you still preserve the inference that she smoked before. Mary didn't regret smoking. You still get, or doesn't regret smoking. You still get the inference that she smoked before. Very, very strong inferences. And in fact, linguists have particularly used a further test as well, so the question test. So if you say, did Mary regret smoking? You get a very strong inference that she smoked before. And under none, it's even more surprising. If you say, none of my students regret smoking, When I say smoked before with regret, it's incorrect. Currently smokes. So smoked before for stop and currently smokes for regret. If I tell you none of my students regret smoking, you get a very strong inference, despite the negative word none, that each of my students currently smokes. And I had the example in the past tense. So that's the reason for the slides being in the past tense as well. Okay, and so none with a presupposition gives rise to a universal positive inference. And so the next question that we were interested in was, can we replicate this effect, which is thought to be encoded in the lexicon and therefore in the memory, in the properties of certain words, with gestures and, in fact, visual animations? And the answer was yes. So here is one of the examples we used. This was an example of removing one's glasses. Okay, it's an example which is fairly easily understood. And of course, it means that you initially had glasses on. But the point is that this inference that you initially had glasses on is not an entailment, it's not an implicature, it's a presupposition. It's going to interact with these tests just like presuppositions. So here's an example. During an experimental session, Valerie watches her graduate students use microscopes and says to the lab assistant standing next to her, for the next phase of the experiment, will a visiting student... So this is a question, and I've produced this gesture of removing one's glasses, and the question was whether subjects got the target inference that Valerie's visiting student has glasses on. And the answer was yes, people got this inference. And in fact, you could do the same thing under none. The results are a little bit less sharp, but they're less sharp even with things like stop. So the beginning is the same, and then you say, for the next phase of the experiment, none of my students will... So you get the inference that each of the speaker's students initially has glasses on. And this is, again, exactly the behavior of a presupposition. It's not the behavior of other types of content. So basically, when we apply this logic to the 7 inferential types, basically, I would say at least 6 of them turn out to be productive. So they turn out to be productive in the sense that you can apply them to stimuli that you've never seen before. So keep in mind that one case I discussed, the case of scalar implicatures, is one which is well understood. There's a productive algorithm based on basically competition among utterances and speakers being as informative as possible. But the other case, presuppositions, this is up for grabs. This is a topic of contemporary debate, and this tells you that the purely lexical theory is probably not the way to go. Now I want to turn to a different kind of productivity that can be assessed by using gestures and relatively uncommon, sometimes very uncommon gestures. There will not be visual animations here, maybe in the future. But the argument will be that several syntactic properties of sign language can be discovered without prior exposure in pro-speech gestures. And I want to turn right away to the first study that we did, and part of the reason I picked this one is that in collaboration with Emmanuel Chamelin, we did an experimental study of this, because this was the first one, and we wanted to establish data that could have been a little bit dubious otherwise. But we start from American Sign Language. American Sign Language displays on some verbs which are called agreement verbs, agreement. So object agreement. So subject agreement exists as well, but I want to focus on object agreement. And so this is an example. This is I give you. So this is the signer position. This is the addressee position. If I'm talking about a third person, it would be I give him. And so the object of give is the object of the sign. And if you had a certain third person situated on my left give something to another third person situated on my right, it would be gives, like this, from left to right. But I'm interested in the target of the verb. And so there is object agreement in the sense that you have different positions in signing space, which are basically discourse reference for different individuals that they could refer to. And so, for instance, the first example from an American Sign Language would work like this. So John with a position A on the right, and then a pointing sign to establish the position more firmly, and then money, I give, but it's really give him, with the object agreement realized by the fact that give targets the right. So that's unsurprising on the basis of American Sign Language grammar. But then I did something a little bit more perverse. I added a sentence with ellipsis to test that this agreement marker genuinely has the grammatical behavior that we expect of agreement markers in general. So I added you, I, not. So there's a verb missing. It's you, I, not, money, give. Okay, so I wouldn't give you money, I won't give you money. But the important thing is that ellipsis has some words missing. And normally syntacticians think that you get the missing words by copying the antecedent. But the antecedent has the wrong form. The antecedent was money I give towards the right. And really what I'm reconstructing is you, I, not, money, give, but I modify the object agreement. Okay? The fact that we can modify object agreement is a property of agreement in general. So for instance, you can say, Mary likes herself, I don't. This is maybe ambiguous, but the salient reading is I don't like myself. And you need to disregard the gender features of herself, and you need to disregard the third-person features of herself. It's a general property of ellipsis that you can disregard these agreement markers. And if you control, if you compare them to things which are not agreement markers, they behave differently. But now the question was, English doesn't have object agreement on verbs. Can we get non-signers who are native English subjects to discover object agreement on the fly with gestures? Okay, so still apologizing for the violent examples, we're going to discuss examples like this one. So you could say, your brother, I'm going to, and it could be realized towards the side. You can also say, your brother, I'm going to, and that's because the position towards the addressee in front of the signer is a neutral position. So it can target the addressee, but it can also be neutral because it's just very easy to realize. What's interesting is that you cannot say, you, I'm going to, this is a weird thing to say. So why? Because you is the object, the target of the gesture is third person, and there's a mismatch. You have to say you, I'm going to, okay? And our subjects got this contrast. But then the next thing is to not just get the contrast, but to show that ellipsis behaves differently in this respect. Okay? And so that's the sentence in C. It works like this. Your brother, I'm going to, and then you too. And now you have no problem understanding your brother, I'm going to, and then you too, I'm going to. But the gesture that you're reconstructing has a different object marking from the antecedent. Okay? And that's exactly the behavior that we saw in American Sign Language, despite the fact that English does not have object agreement. Okay. What kind of rule is this? Well, chances are that this is a rule that syntacticians call universal grammar. This is something that you find in language after language, and it's not super surprising that people are able to infer this kind of without prior exposure. Now, this is just the tip of the iceberg. So there's a whole list of non-trivial properties of sign language which you can arguably replicate on the basis of pro-speech gestures. We don't have experimental data on these, so these are more like consultant-based judgments, but there's an entire research program that one could develop, and in fact, that my colleague Brent Strickland started developing in another case earlier than the paper I just discussed, which was a study of telicity, the understanding of telic marking of signs by non-signers. This was, I think, a 2015 paper. Now, having given you an example of a property of sign language which is likely inferred because of universal principles of language, I want to zero in on a different case which we're working on currently. So this is now zeroing in on a very, very special corner of sign language in general, and American Sign Language in particular, which are called classifier predicates. So classifier predicates are sometimes called, so this was what Sandro Zucchi said, they are hybrid creatures. They have a conventional form. So this is, for instance, this classifier predicate for a vehicle of any sort. It could be a car, it could be a bus, etc. It doesn't look like a car or a bus. So the lexical form need not be iconic. But the movement, the position in signing space of the movement is entirely free, unlike that of other signs, and it's interpreted iconically. So for instance, I could say this in order to say that a car drove by, but I could also say this in order to say that a car drove by with this kind of movement. Now, what's very interesting is that American Sign Language has a basic word order, which is SVO, just like English or French. But with classifier predicates, there is an old claim, going back to Liddell, that their preferred word order is SOV or sometimes OSV. So they have a different syntax. And in fact, this is something that we've replicated. These are pretty subtle contrasts, but they are fairly stable within our consultant and even across consultants to some extent. So this is the example that we studied. There's all sorts of controls, which I won't tell you about. So this is about basically yesterday, a will, a person, and then you have the classifier predicate representing the will, and it's going to perform a complicated movement, and then it's going to swallow the person. And I gave you the version which would be one possible version with the subject and object before the verb. So that's a case in which, because this is a classifier predicate, people actually prefer, or at least our consultant and our consultants prefer, in this case, OSV or SOV rather than SVO. Now, the proposal that we made following an intuition, but not the precise theory at all that is in earlier literature, in particular Napoli and colleagues, was that the reason classifier predicates override the basic word order of American Sign Language is that they compose with their arguments in a completely different way. That basically what you have, and maybe the impression that you had when you saw this example, is that I create a little animation, right? So there's a whale, and there's a person, and then the whale moves and swallows the person. But why would you put the arguments before the classifier predicate? Because if you were to visualize the scene, you would see the participants to the scene before you see the action. And that connects the iconicity of the predicate to the fact that it overrides the basic word order. But of course, this makes a prediction. The prediction is that if you replace swallow with spit out, well, when a whale spits out the person, initially the person is in the whale, so you don't see the person. And so you should not position the object before the verb, you should position the object after the verb, and lo and behold, simplifying a tiny bit, this is exactly what we found. So in this case, the preference was to say whale, and then the classifier predicate, person. And you end with person. And then the question was, can we replicate this completely weird behavior of classifier predicates within, not English in this case, we did French. It wasn't an experiment, it was a survey of 10 French consultants, and it worked basically in the same way, except that instead of using classifier predicates, which were lexical forms, we use improvised gestures. So it was a crocodile and a ball, and the crocodile eating the ball. Okay, so that was one case. Or it was a crocodile and then spitting out a ball. And we basically, everything was modeled. I mean, we were really trying to import American Sign Language into French, and so we modeled our examples on the American Sign Language examples. And to cut a long story short, we found the same kinds of results. And there's actually two results. And one is, in fact, more informative than the other. There's a preference for the object before the verb in the eat up case, where you see the person before you see the action. And there's a preference for SVO in the spit out case. But also there was a very striking result in American Sign Language and in French gestures, which is that if you put the object before the verb in the classifier predicate case, meaning spit out, or in the gesture meaning spit out, you get the wrong meaning. So for instance, when you say crocodile ball, and you try to say spit out, you get the meaning that the crocodile spits something on the person. You don't get the meaning that the crocodile spit out the person. And that goes completely in the direction of the iconic analysis that we gave. So, conclusion. There are multiple cases of what you might call zero-shot learning in that case, from gestures and, in fact, sometimes from visual animations. The first case I mentioned is one in which a well-known pragmatic algorithm, a well-understood pragmatic algorithm, is responsible for the generalization. For presuppositions, the debate is currently open. I think it's a cognitive algorithm. Some people think it's a communicative algorithm, but the point is it's not well understood, despite my best efforts. In the case of object agreement, this is probably something that people call universal grammar. And in the case of gesture sequences in highly iconic cases, this is probably something completely different, which is the fact that there is in sign language, and in fact to some extent in spoken language as well, a mix of two modes of composition, normal composition and iconic composition. Thank you very much.